Now, corresponding question, find I naught with the help of Norton theorem. That is I naught. Okay, here 6 volt and here 2 milliampere is the independent voltage and current source. That is 2 kilo ohm, here 4 kilo ohm, that is 2 kilo ohm, and that is 5 kilo ohm. Okay, so how can do it? First of all, I know that if you determine Norton equivalent, so this one is removed and that one is RL. Okay, load resistance, assume load resistance. Okay, and this one is consider X and that one consider Y terminal. So first of all, remove 5 kilo ohm. After that, making the circuit, that is plus minus 6 volt, and this one is 2 milliampere. Okay, circuit like that one. Okay, and here 2 kilo ohm, that is 2 kilo ohm, and this one is 4 kilo ohm. Okay, and here that is 2 kilo ohm. Okay, and that one is X and that one is Y terminal. Clear or not? Now, so we are focus on first of all IN. First one we are focus on IN. IN means ISC. Okay, that is Norton current. So if you determine Norton current means that circuit, here plus, here minus, here 2, sorry, here 2 milliampere in upward direction, and that one is 6 volt, and this one is 2 kilo ohm, and that one is 4 kilo ohm, and this one is also 2 kilo ohm, and this two terminal are, that is ISC. Okay, so how can we determine ISC? If you apply superposition theorem, okay, with the help of superposition theorem. Okay, according to this theorem, if one source is active, okay, if 6 volt is active, 6 volt is active, then 2 milliampere is reactive. Okay, reactive means that is remove it. Okay, that is 2 kilo ohm, and that one is 4 kilo ohm, and after removing means this is open circuit, means 2 milliampere it's a behave as an open circuit. Okay, that is 2 kilo ohm. Then we got current ISC1. Okay, ISC1. Now if you read the circuit again, that is plus minus 6 volt. Okay, and that one is 2 and that one is 4, 4 kilo ohm, here 2 kilo ohm, and that one is 2 kilo ohm, and here ISC 1. Okay. So how can we determine? You can apply here with the help of source transformation. Okay, using source transformation, 6 volt is written as 3 milliampere and 2 kilo ohm like that one, and 4 kilo ohm, 4 kilo ohm like that one, and here 2 kilo ohm. Okay, basically what about source transformation? Plus minus 6, and here 6 volt and here 2 kilo ohm is converted into current source, and that is 2 kilo ohm, and 6 by 2, that is 3 milliampere. Okay, that is source transformation. Okay, clear? Now after that, if you see very carefully, these two are parallel, so combination of these two, 8 divided by 6. Okay, so if you make the circuit again, that is 3 milliampere, and combination of these two, we got 8 by 6 means 4 by 3 kilo ohm, and that is 2 kilo ohm, and here ISC. So here apply current division rule. 3 into 4 by 3 divided by 4 by 3 plus 2. Now 3 into 4 whole divided by 4 plus 6. Clear? That is 12, and divided by 10, we got 1.2 milliampere. That is ISC1. Okay, clear or not? 3 2 just 6, 6 plus 4 10, 1.2 milliampere. If you end out, then comment it. Now next one, we have focus on if 2 milliampere is active source, 2 milliampere is active, and 6 volt is deactive. Means, what is the meaning of that one? Plus minus 6 volt, basically this one is a short circuit. Okay, so after making circuit like that one, here 2 kilo ohm, here 4 kilo ohm, and that one is 2 milliampere, and that one is 2 kilo ohm, and that is ISC2. Clear or not? Okay, this is short circuit. So how can do it? First of all, if you see very carefully, 2 and 4 are parallel. So combination of these two, like that one, and this one, not parallel. You see very carefully, not parallel. If you see very carefully, if x, and that is, sorry, x1 here, x1 here, y, so you can say that 2 and 4 are parallel. 2 and 4 are parallel. Okay, here 2 milliampere, and this is y1. So combination of these two, 8 divided by 6, that is 4 by 3, 4 by 3 kilo ohm. Okay, here x1 and y, here y, and that is 2 kilo ohm, and that one ISC2. So basically you can say that ISC2 this equal to 2 milliampere. Okay, ISC2 is a 2 milliampere. So finally IS this equal to ISC1 plus ISC2, that is 1.2 milliampere plus 2 milliampere, we got 3.2 milliampere, that is ISC2. Clear? ISC, that is IN current. So 3.2 milliampere is the IN current. After that we have focus on RN. Okay, Norton resistance RN. Okay, so how can we determine? RN means all independent source reduced to be zero. Okay, it means all independent voltage source reduced to be open circuit, short circuit, and current is open circuit. So 242. So first of all, if you make voltage source is short, this is 2 and that is 4 kilo ohm, here 2 kilo ohm, and here open circuit, that is 2 kilo ohm, that is RN. Okay, so Rn is equal to 2 plus 4 by 3. So finally we got 10 by 3 kilo ohm. So Norton equivalent, Norton equivalent Rn is how much? 10 by 3 kilo ohm. Okay, and In 3.2 kilo ohm. sorry, milliampere, milliampere. So if you make the circuit IN, here RN 10 by 3 and IN is okay, and that one 5 kilo ohm, that is 5 kilo ohm IL. Okay, our motto determine IL, so IL is written as finally IN into RN divided by RN plus RL. Okay, so 3.2 into Rn is 10 by 3 whole divided by 5 plus 10 by 3. So we got 3.2 into 10 divided by 15 plus 10, 25. Okay, so 3.2 into 2 divided by 5. So finally we got 64 divided by 5. So 1.28 milliampere. Okay, if you take calci, then you can use 6.4 divided by 5 is the right answer. Okay, make it make it. Okay, maybe our calculation is wrong, maybe, but procedure is right. Okay, sometime can calculation mistake also always. Okay, but procedure, always follow procedure and you try yourself. Okay, make it. If any doubt, then comment it, I will discuss again.